Hi guys. So today we're going to talk about mole to volume conversions. This is one of the last conversions that we'll talk about for this unit. And the nice thing about this is it's going to segue us nicely into what we'll be talking about for Unit 7, which is going to be solutions. So the first thing we need to talk about is STP. So STP is going to stand for standard temperature and pressure. Um, Standard temperature and pressure is saying we're going to automatically assume that we're in an environment that is standard. So a standard temperature is typically 273.15 Kelvin. Our standard pressure is typically 1 atmosphere. And typically, if you have 1 mole of a particular substance, a standard volume is 22.4 liters. So we're specifically today going to be talking about our standard volume that we have and the fact that for every 1 mole we'll have this particular volume. So before I do this, I need to get my tools up. Just a sec. I'm going to use black today. Okay, so first thing we'll talk about is mole to volume. So our relationship in this case is for every 1 mole, we have 22.4 liters. This is going to be the same regardless of any substance that you're going to have. So you can see in the picture here, we have helium, nitrogen, and oxygen. If you have 1 mole, we'll see the gas as 22.4 liters. So if you're given moles and you're trying to find liters, what you can do is take your given and multiply it by your liter value. So my example here, you can see that my given value is going in its normal spot. And then I have to put in the bottom right quadrant my mole value because that's the same as my given unit, which leaves on the top right here 22.4 liters. So really what we're doing is we're taking that liter value, 22.4, and multiplying it by our given. So we're going to do some practice. Our first one says, how many liters of nitrite are in 3.2 moles? So we have a given. Our given is that we have 3.2 moles. Our unknown, what we're trying to find out, our unknown is the number of liters. So I'm just going to put number of L. And then our relationship is that for every 1 mole of something, it's going to equal 22.4 liters. So now I can just go ahead and plug in. My given goes in its normal spot. Oh goodness. My pen's lagging. Sorry guys. So I have 3.2 moles. And then my 1 mole goes on the bottom right quadrant and 22.4 liters goes on the top. Sorry, we're going to have a lot of technical difficulties because this is the first time I'm using it. So what we're doing is we're doing 3.2 times 22.4 divided by 1. What we should get for the answer here is about 71.68. The units for that, since we're crossing out this mole value, we're left with liters. So we have liters of nitrite, so liters of NO2. Okay, so I want you to pause the video for a second because I want you to try number 2. And then once you have completed that, then you can keep going. So I'm going to give you a second to do that. All right, so you should have paused the video to try a little bit on your own, and I'm just going to go through the answer. So our given in this case is that we have 0.11 moles of beryllium. And that's moles of Be. Our unknown is that we're trying to find the number of liters. And our relationship is that for every 1 mole, we'll have 22.4 liters. So now when we're plugging in, you could use a stoichiometry grid. I always suggest using those. However, if we know that we're multiplying, you can just think, I'm going to take my given, I'm going to multiply it by our 22.4 unit value. But I like to use the grid because it's especially helpful when we'll move on to more complicated things. So our given is going to go in the usual spot, so 0.11 mole. Bottom right quadrant, it has to be the unit that's the same, so the 1 mole is on the bottom, and then our 22.4 is in our desired unit box. So 22.4 liters. So we're just multiplying 22.4 by 0.11. When you multiply that out, you should get about 2.5 when you round. So 2.5, and that's liters of beryllium. Okay, so that's going from mole to volume. So now, of course, we're going to talk about going from volume to mole. So I'm going to the next page. So when you're doing volume to mole, you're now changing how you're using the relationship. Since we're given a liter value, that means our liter unit value in our relationship has to go in the bottom right quadrant, with our mole value unit, it will go on the top right quadrant. So we can see here in this example, it says how many moles of oxygen. You can see we started out with our liters. So now our liter values in that bottom right quadrant instead. So we're going to practice. This says how many moles of C3H6O2 are in 18.10 liters. So our given is that we've got 18.10 liters, our unknown number of moles. And our relationship is that for every 1 mole, we have 22.4 liters. So now when we're plugging in, we have a liter value in our given. So that means that my liter value now needs to be in that bottom right quadrant. So that's why I'm putting the 22.4 there instead. And then 1 mole goes on the top, which is good because we're trying to get to mole right. So what we're doing is we are taking our given value and dividing it now by 22.4. Try to calculate this out on your own. But what you should get is about 0.81 moles. And this is the moles of the C3H6O2. Okay, so I would suggest pausing the video again. Try number 2. It says how many moles of sodium chloride are in 25.2 liters. So try this one on your own, and then we'll go over the answer. Okay, so you should have paused the video. If you didn't, that's okay. I'm just going to go through the answer. So our given is that we have 25.2 liters. Our unknown number of moles. And our relationship is that for every 1 mole, we have 22.4 liters. So when we're plugging in, our 25.2 liters goes in that top left. Bottom right is going to be my liter value, so 22.4. That means the 1 mole is going to be on the top. So what we're really doing is we're taking our given, dividing it by our liter value. So 25.2 divided by 22.4. When I round, I get about 1.13. And the units for that are moles of sodium chloride. Okay, so before we go, I want to talk about this little diagram here that's on the bottom. So this is a comprehensive roadmap that can help you get to anything. So it's one direction. You can see the one way here at the very bottom. So you'll read it left to right. So what we just did was volume. So say you're given volume, and you can see here it says at STP, which is very important because if we're not at STP, we can't assume that for every 1 mole there's 22.4 liters. So if you're given a volume and it says it's at STP, you can divide whatever that is, divided by 22.4, you get moles. Now, say you start at moles, so you start here, you can use the 22.4 value to get to volume. So you'll read it left to right. And you could do the same thing for the particles or the mass, which are two of the main ones that we've gone through. So if you're given mass, divide by molar mass to get moles. If you're given moles, you multiply, so over here, molar mass to get the mass. And then last thing for particles, say you're given particles over here, you're going to divide by Avogadro's number to get to moles. And then if you're given moles, you'll multiply by Avogadro's number to get to particles. So that's more of a resource for you. Hopefully that helps. That way, if you get stuck on your stoichiometry grid, you'll still have that. Okay, so that's all I have for you. So what you'll want to do now is take the concept check that's on Schoology, and then we'll be good with this content.